Software development security. It's the process involving certain people and practices that ensures an app has confidentiality, integrity, and availability. Why would anyone go through all that effort? Well, the unfortunate reality of working in this field is there are many valid and concerning threats that people must be aware of on a daily basis. On the app side alone, things such as viruses, worms, agents, and Trojan horses are common ways security may be compromised. The applications themselves will most likely have security vulnerabilities that are created by the people making the app software, intentional or not. The software development lifecycle, or SDLC, is a structured way of building software applications that take safety and security into consideration. Every phase will stress security over and above existing sets of activities, and all of them can have varying amount of steps, but all will have the same core building blocks as shown here. Concept and planning. Purpose of this stage is to define the application's concept and evaluate its viability. This includes developing a project plan, writing requirements, and allocating resources. So here you want to use SDLC discovery. This will ensure a team will address security issues as early as possible. Next, security requirements. Having a list will help identify and fix potentially non-compliant areas of this project. Security awareness training. Basic security training establishes a security mindset for all project participants. Architecture and design. Purpose of this stage is to design a product that meets requirements. This includes modeling the application structure and its usage scenarios, and choosing third-party components that may speed up development. Here, you're going to want to use threat modeling, which uncovers possible threats early, thus reducing its associated costs, and also lays the basis for future incident response plans. Next, you're going to want to use secure design. Early design reviews assist in identifying features exposed to security risks before they are implemented. Next, you're going to want to use third-party software tracking. Regular checks of third-party software will help spot gaps in potential areas. Implementation. This stage here is where the application is actually created. Here, you write the code, debug it, and produce stable builds suitable for testing. Secure coding, which enforces secure coding principles, eliminates many trivial vulnerabilities and frees up time for other tasks. Static scanning. Daily use of static scanning tools uncovers mistakes before they can make their way to the application builds. And code review. Timely reviews help developers flag and fix potential issues before they shift to other tasks. Testing and bug fixing. Purpose here is to discover the correct application errors, includes automatic and manual tests. Dynamic scanning, which in addition to discovering regular vulnerabilities, dynamic scanning also pinpoints configuration errors that can impact security. Fuzzing. Automatic fuzzing tools improve protection from attacks that use malformed inference, such as SQL injection. And penetration testing, which would bring in external experts that rely on their knowledge and intuition to reproduce attack scenarios that may have been overlooked by your own team. Release and maintenance. Here, the application goes live and many instances running in a variety of environments. Eventually, new versions and patches will be available, and some customers may choose to upgrade while others keep older versions. Environment management. Such monitoring improves the overall security of the application. Incident response plan. Swift execution of the response plans is crucial for triage and repair of any security breaches that may come forth while working on the project. Ongoing security checks. Regular checks protect the application from newly discovered vulnerabilities. End of life. This is the point where software is no longer supported by its developers. Apps that store sensitive data must be subject to end of life regulations, which is data retention here. Double checking your company's retention policies for compliance with legal requirements reduces the risk of unexpected fines. And data disposal. Proper data disposal at the end of life keeps such information confidential and prevents data breaches. The real cost? Well, Developing secure and safe software is extremely critical to a company's bottom line. The impact of any malfunction or security breach can result in massive recalls, millions in lost revenue, loss of sensitive customer data, and a headline in every big media outlet. The amount of software in everything from automobiles to investing trade applications, more companies than ever are feeling legal and financial pressure to ensure the security of their code. Faced with having to maintain software quality and security while constantly innovating, companies look for new ways to further reduce overall program risk.